Welcome to our video tutorial here involving verifying trig identities, typically with sum and difference formulas or double angle formulas. The problem that we are going to try to establish, or the identity that we are going to try to verify, is listed in the top portion of your screen. Perhaps you want to hit pause and try it out before we proceed. Okay, so here's the deal. The key to this problem is we've got an 8 theta, we've got a 5 theta, we've got an 11 theta. Can we somehow incorporate an 8 into both an 11 and a 5? In other words, we could look at 8 theta with something to give us 11 theta, and we could look at 8 theta with something to give us a 5 theta. Here we would be adding 3 theta, and here we would be subtracting 3 theta. Now it's frequent that when we go about this in a trig identity proof, things might cancel out and combine nicely and make our lives much easier in verifying the identity. So the first thing that we are going to do is rewrite each of the inputs. 11 theta is going to become 8 theta plus 3 theta, and 5 theta is going to become 8 theta minus 3 theta. At this point, we can use the sum and difference of sine angles to rewrite our numerator. Now in this numerator, we do want to kind of keep things together. So this portion that I'm highlighting in magenta gives us this. So the portion that's been highlighted in magenta yields the highlighted portion in magenta. And what we're highlighting in orange yields the part that we're highlighting in orange. Really what's going to turn out being the key as we proceed through this identity is this plus and this minus are going to cause these two terms to cancel. And then look at what happens with the other terms. Sine of 8 theta, cosine 3 theta, those are actually going to combine. Again, we will see that as we proceed through the proof. Now we will use the sum and difference of cosine to simplify our denominator. And something similar is going to happen when we look at the denominator. So now let's keep everything in mind. This blue underlined portion and this blue underlined portion are going to cancel. This portion right here is going to combine with this portion right here, giving rise to 2 cosine of 8 theta cosine of 3 theta. Remember, something similar happened up top where this is going to cancel with this because of the opposite signs, and we're going to have 2 sine of 8 theta cosine of 3 theta from up top. So now what we're going to do is simplify this expression in our next step. And when we simplify into the next step, we're getting rather excited because look at where we want to end up at the tangent of 8 theta. And look what's going to happen here. Cosine of 3 theta cancels, the 2's cancel, and really we're going to be very close to what we want. So after we do those two cancellations, we're left with the sine of 8 theta divided by the cosine of 8 theta. And last but not least, using the fact that tangent is sine over cosine, we end up where we want to be. And again, this entire proof stems from the importance of looking at something like 11 theta becomes 8 theta plus 3 theta, and 5 theta becomes 8 theta minus 3 theta. And then what's going to pan out, now hopefully this will be the case with regularity, is things cancel. The items in magenta that I'm highlighting, remember they canceled as we work through this proof, and the items that I'm highlighting in blue also canceled as we work through this proof. The other nice part is the remaining terms combined. So sine of 8 theta, cosine 3 theta combined, we got 2 of them up top. And a similar thing happened in the bottom, cosine of 8 theta, cosine of 3 theta combined, and we got what we wanted. So especially in this unit with trig identities, watch for how the sum and difference of selectively chosen angles can make a significant difference in helping you work through an identity proof.